Hey everybody, we're going to talk a little bit about Chapter 2 definitions. Um, this information will be found on our upcoming exam, but you will not be tested on it except in the exam. Um, and we're really only going to be talking about some of the definitions from Chapter 2, just sort of as an introduction to um, logic and some of the definitions that happen with logic. So, you should have a note sheet with you. And we're basically going to go through that, and then you'll have a little bit of time to practice with these new words and sort of understand what they mean. Um, so, first definition is conjecture, and what a conjecture is it's an unproven statement that is based on observations. Um, so, anytime that you take a guess on something as to what's going to happen based on things that you've seen, what you're doing is you're making a conjecture. So basically, a conjecture is a fancy word for an educated guess. And if you want to write that down, you can. Next word, inductive reasoning. Um, Inducting basically means that you're using past cases to make a statement about a current one. So, as it says here, inductive reasoning is when we use specific cases and examples to form a conjecture. So we're going to use the past to help us form a guess as to how things are going to work. And to compare with inductive reasoning, there's something called deductive reasoning, which is where we use facts, definitions, properties, and logic to reach a conjecture instead. So the difference is, deductive reasoning has much more to do with using things that have been proven already, things that we know are for sure true, and tying them together to reach a conclusion, whereas inductive reasoning is more looking at how things have worked and using that to figure out what's going to happen. So, an example, and this isn't on your sheet, but you can take a look at this anyway. Would this be inductive reasoning or deductive reasoning? If we make a statement like, the temperature has been less than 30 degrees for the past week, so it will be less than 30 degrees tomorrow. Well, thinking about that, um, is that more of us using a definition, a property, logic, facts to reach our guess? Or is that more us looking at a pattern of past things and making a determination based on that? And the answer is, of course, the second one. This is more inductive reasoning, because we're not really using a definition, or we're not really using we are using logic in a sense, but we're not using really formal logic. We're not ruling things out based on things happening. What we're doing is we're just saying, because this is how things have been working recently, this is how it's going to be. So that's inductive reasoning. Deductive reasoning is more like, if you imagine what a detective does, that's more deductive reasoning, where they'll look at the evidence and then make a conclusion based on that. All right, moving on. We have conditional statement, and that is a logical statement that has two parts, usually written as an if-then statement. So they're going to read if ... then ... And we're going to see some examples coming up. This one example is here. If the wind chill is over -45, then we won't have class. That is an example of a conditional statement. There's the if ... then ... The two parts have names. The first part is called the hypothesis. That's the part of the conditional statement after the if and before the then. In the example from above, that would be the wind chill is over -45 degrees. And then the other part is the conclusion, which is the part of the conditional statement after the then. In our example here, that would be we won't have class, the part after the then, right over there. Next, we have the idea of the converse, and the way that we get our converse statement is by switching the hypothesis and the conclusion. So, looking back for a second, our conditional statement was if the wind chill is over negative 45 degrees, then we won't have class. The converse would be achieved by switching we won't have class with the wind chill is over negative 45 degrees. So we're going to get, if we don't have class, then the wind chill is negative 45 degrees. Now think about the truth value of this, whether it's true or not. Is it necessarily true? And the answer, of course, is no. If we don't have class, does the wind chill have to be negative 45 degrees? Of course not. We could have too much snow. It could be a weekend. It could just be a break. So there are many ways that we can not have class when, besides the wind chill being negative 45. So these converses and even these original statements aren't always true, and you should be on the lookout for that. When they're not true, you should be able to come up with a counterexample. And that's an example that shows the hypothesis as being true and the conclusion as being false. So applying it for the converse that we had above, like I said, there are many cases where we don't have class, but the wind chill isn't negative 45 degrees. Any of those that I mentioned would be counterexamples. The weekend is a counterexample to this because we don't have class. This is true, but the wind chill is not negative 45 degrees. This one is false. So you can come up with many counterexamples sometimes, unless it's true. And lastly, we have the idea of the biconditional statement. And what that is it's a statement that uses the phrase if and only if. The special thing about biconditional statements is that these are statements where the converse is always true. So, one example is, if the wind chill is 35 degrees or more, then we have a wind chill warning. This is true, and that's because wind chill warnings happen when we have a wind chill of negative 35 degrees or more. So, we could also say, if we have a wind chill warning, then the wind chill is negative 35 degrees or more. It works either way. And what that means is we can actually rewrite this as we have a wind chill warning if and only if the wind chill is negative 35 degrees or more. And you can only write it like this using the words if and only if. You're only allowed to do that when you have a statement whose converse is also true. So, those are the definitions. What you should do next is try out the problems on the back of the sheet. They're going to have you use the definitions. If you get stuck on things or don't quite get what to do, ask for help. Or make sure that you get questions ready, at least. And we'll talk more in the class. So, thanks for watching.